Okay, sketch the hyperbola. Is this in standard form? How do you put it in standard form? Divide by 16, right? So when I divide by 16, 16, 16. Now I've got x squared over 4 minus y squared over 16 equals 1. Okay, that's in standard form. What is the center of the hyperbola? It's 0, 0. And does this open, is it open, is it horizontal or vertical? How do you tell from the equation? Try again. Everybody just said vertical. Try again. Remember, the first term, the positive term is x, so it's horizontal. Right? Whatever is that first term, positive term. And don't write it mixed up. Don't make that negative and that positive. Right? This is the form. It's always positive term and then negative term. So we know that it's got the axis goes like that. We know the a, right? A squared is 4, so a is 2. Okay? So a squared, so a equals 2. That tells us that we should go to the left 2 and to the right 2 to find the vertices. Okay? Now, here's where we introduce b in terms of what b means on the graph. B squared is 16, so b equals 4, right? So after you've found your vertices with a, you're going to go in the perpendicular direction, the b distance, right? So go up 4 and down 4. Okay? And those 4 points are going to be the midpoints of a rectangular box. So, like this. So sketch yourself a box. Right? That's why you use the B, right, to make this box. And then once you've got that box, then you're going to draw the diagonals of the box. So okay, those diagonals are asymptotes. And what is an asymptote? Well, technically, the thing we know for sure about an asymptote is that it's a line that the graph will approach but never quite touch. Right? So if those are the asymptotes, and we know what the vertices are, right? This was the vertex and this was the vertex. Then you, starting with the vertex, you draw the hyperbola approaching the asymptotes. Okay, so you can see the center. You can see the center from the standard form. You know what the A is. You know what the B is. You use that to make the midpoints of the box. Draw in your box. Draw the diagonals of the box. And then sketch each branch. Right? If it's horizontal, it'll go like this. If this thing was vertical, I would have sketched it up here. Right? Now, both of these, those two lines, have equations. And we could tell them from this one very easily from the graph. Right? We would go, this line right here has a y-intercept of 0, and it has a slope of, you go up 4, over 2, up 4, that change in y is 4, change in x is 2, so it's 4 over 2 is 2. So that line right there is y equals 2x. How about this line? No, this one has a negative slope, so it's y equals negative 2x. Now, what is the slope actually in this case? Remember, we went up and down. That was a distance b. And the left and right, that was a distance a. So actually, these two equations are actually this: y equals plus or minus b over a times x. And if it's opening up horizontally, it always would be. Right? The slope would always be the b over a, because that's how you came up with the box, to draw the diagonals. Now, this one happens to be centered at the origin, but they're not all centered at the origin. So how do we move things around the graph generally of any kind of a shape? Well, you would subtract the y shift, y minus k equals plus or minus b over a times x minus h. Right, that would shift it right and left according to the h, up and down according to the k. So if it wasn't centered here, it would be centered wherever those 2 points were. Now, on the next slide, I'll give you the official form of this. It's not exactly this, but notice if I just add k to both sides, right, then you're going to get these. Right? That's this form. For a horizontal hyperbola, it's k plus or minus b over a times x minus h. Now, the only thing that changes for the vertical is that now your A was telling you how much to go up and down, and your B was telling you how much to go left and right. So the slope is A over B, not B over A. Right? Horizontal, it's B over A. Vertical, it's A over B. I'm going to stop that.